Good afternoon, everybody. I hope you had a good lunch. Following on from our small nuclear reactor salesman, I've decided not to give my conceptual paper. I've decided to ski off piste here a little bit. And also Alex has got to get back to Guernsey, so I don't have 45 minutes. I've only got like 25 minutes. It's given me a chance to just cut out some of the fluffy bits. This is going to drive you completely mad because there's not much data in this, okay? There's not much evidence in all of this, okay? So basically, for the last 15 or 20 years, I've been curious about tidal energy. And I haven't really bothered with it very much until recently, when it became apparent to me that for some reason, it was being left out of the equation. Wind and solar were dominating the debate, and all of a sudden tidal energy became the sort of Cinderella of the discussion. And I genuinely think that's still the case at the moment. Now, I first read about this in a paper, which I've lost, on my birthday on the 13th of July 2010. And this was a report written by the Planning Committee. And there have been several reports written by the Planning Committee about tidal energy, none of which have made it into the discussion, or as far as I can tell. So the basic idea here comes from the French. Just south of here is St. Malo, and there's a thing called the Rance Barrage, which I'm sure most people have heard about the Rance Barrage. Now, the interesting thing about the Rance Barrage for me was that it was completed and commissioned in 1966, and it's been producing energy every day since. And the EDF who own the barrage are maintaining that it's got another 25, 30 years left in it yet. So the first point I'm going to make here today is nuclear energy and all these other different systems may claim different life periods, but as far as I'm concerned, tidal energy in a reinforced concrete structure has got a potential lifespan of about 100 years, and anything that's bolted onto it by way of turbines or whatever, obviously they last as long as they last. Now, the problem with the Rance Barrage is that the turbines are mounted in the water. Now, we all know what salt water can do to mechanical objects, the underside of boats. It's a very aggressive environment in which to operate anything of that nature. So the first thing that occurred to me as an engineer was, well, do we actually have to locate the collection from inside the water? And the answer to that is no. The idea was that if you can construct a 10 metre by 10 metre reinforced concrete pod with a lid on it, which is positioned just below low water mark, as the tide comes in 8, 10, 12 metres and goes down, it compresses the air within this pod. And that air can then be regulated by valves so that it could turn a hydropneumatic turbine through a gearbox into an alternator and produce electricity. Very quickly, that's the idea. Now, Rolls-Royce at the moment are looking at this, and we're having a chat with them about it, but I'm not going to go down a technical path here on all of that. The advantage with this is that because the gubbins is located at ground floor level, it's very easy to access from the back of vehicles, high-abs, cranes. The mechanical side of it is easy to access, and also you can put it in a crinkly tin shed or whatever and protect it from the elements, so it's not subject to the ravages of Mother Nature. Now, in Jersey's case, I thought, well, where are we going to put something like this? Because the Rance Barrage is 750 metres long and has 24 turbines. So I looked at the port of St Helier, if we can pop up to here. That is a drone shot above Elizabeth Castle of the port of St Helier. You can see in the bottom right-hand corner the Dog's Nest Rocks, and anybody that frequented the La Folle pub many years ago, that was always on the agenda because all the fishermen, everybody that had anything to do with navigation, that's a deep water berth which has gone begging for many, many years. Now, that rock formation just happens to be 700 metres away from the main harbour mouth. And it runs down the side of a very busy shipping lane, because obviously St Helier Harbour's only got one exit and one entrance. So we have an existing busy shipping lane alongside which we could construct a 700-metre reinforced concrete pier. Now that pier, if broken up into 10-metre pods, would comprise 70 pneumatically driven turbines. Now, even at 3 kilowatts each, that's 200 and something odd megawatts. That's quite a lot of electricity being generated from that arrangement. The USP here is that that would also provide Jersey with 5 or 6 extra years of landfill. It's also only 500 metres away from the JEC La Collette station in terms of not needing cabling. And it would provide a deep water berth for larger ships, so that the cost of shipping to and from Jersey, cost of goods, could be reduced. We don't need small boats bringing it backwards and forwards. We could have larger boats bringing goods and materials backwards and forwards. And finally, if it was connected to the fuel farm, it could produce a very useful mid-channel refueling berth. So if you've got a boat in London or a boat in Amsterdam and you want to go to the Mediterranean or the Atlantic, you can stop in little old Jersey, you could buy a shed load of fuel and off you go, because the fuel in Jersey is cheaper. So in a nutshell, that's the proposal. Now, could we just move on to the next one? Now, this business with I keep going on about the Rance barrage, but for me it's important because it's proved that an arrangement like this, if constructed properly, can last a very long time. And the problem here is cost. Kirsten Morell's first comments were all about cost. So what we're talking about here today is a scheme, a deal, whatever you want to call it, where the actual initial capex cost could receive multiple contributions towards. The tipping charges in Jersey at La Collette are £750 per 16-tonne lorry load, and there are hundreds of thousands of tonnes of potential filling in there. So there's a tipping charge, there would be a refueling charge, there would be a berthing charge, and also, if anybody wanted to bring a cruise ship along or something with a couple of thousand people that wanted to go to St Helier, they could bring that along as well, just for good measure. So all of these things would contribute, as well as the actual cost of the electricity, to whoever the customer was. And this brings us back to where we were before, because the land that I'm talking about is owned by the public of Jersey. And I think it's not beyond the realms of possibility that that could be leased for 99 years, upon which you could then construct this arrangement. We're not talking about selling the family silver. We're not talking about doing any funny deals. It would be a straightforward lease along the same lines as we were talking about leasing part of the seabed to a wind farm person. Well, this would just be part of the ports of Jersey. And of course, Jersey would benefit, again, going back from the point of view of employment, because all of this would need maintaining, the initial installation costs, this would produce jobs, and it would all be in an established St Helier, which is the capital of the island effectively. Well, I think that little slide there, I thought we'd erased that one.
Keep going if you want.
Yeah, if you want to keep going, please. There's a couple more shots of the area in question. The centre photograph shows where the corner of the gas refueling berth is before you get into the harbour heads of St Helier. And the right-hand shot shows you the extent of the Dog's Nest reef. So it's because it's a busy shipping lane, it's the finger of part of a Ramsar site, and obviously you've got to be very careful about these things. But because it's an established, busy shipping lane, I'm hoping, because we haven't had a chance to do any marine studies or anything of that nature, I'm hoping that that wouldn't be an impediment to the actual construction itself. This here is a thumbnail sketch of where the 70 pods would be positioned along the wall. That little square in the middle would be where all of the control equipment and any other stabilization equipment would be positioned. And you've got the additional landfill, you've got the land around it, which you could put to other uses if you so desired. As far as the problems of the tide are concerned, obviously you've got a tide which is coming up and going down for 21 hours a day. But you think you've got a period where at high tide and low tide, there's not much happening. And obviously that's where a backup system would be necessary to this, so that you keep the supply of electricity constant, and we try and avoid a lot of these problems with the balancing of the grid that you would have with wind and solar. It's something that we're looking at the moment, but because this is a concept, that's very much in hand. That also shows how close the site is to the La Collette chimney and the existing power station and energy from waste plant. Can we flip over to the next one? Now, using historic data from the Rance barrage, we've done a few calculations as to how much that cost in the early 1960s, and allowing for inflation and build and various other things. We've done some numbers on it so that the basic cost of the scheme would be just 1 billion. Now, funnily enough, if I've understood correctly, that's about a third of what one of the small nuclear reactors would cost, and doesn't have the decommissioning or end of life issues, because the worst case scenario here is that you remove all of the stainless steel turbines from the top of the pier, and you've got a perfectly good harbour that you can use for other things. So that's where those numbers come from. The hydropneumatic turbines, 70 of them, 20 million a pop, which these are figures that we've got from Rolls-Royce. The building enclosures, batteries, transformers and so on. This is all taken from general, it's very general, but just to give you an idea of how much money we would be talking about. But the idea of this, of course, is that this would be dealt with by venture capitalists. This wouldn't be taxpayers' money. This would be something that was built at somebody else's cost, but for the benefit of the island. And of course, once it's there, they can't easily remove it. Once they've committed to it, it's there for some time. Could we move on to the next one? So the construction build period would be in the order of 5 years. It took the French just under 5 years to build the Rance barrage. So I think it's fair to assume that something that's shorter, 50 metres shorter, would take about the same length of time. I've mentioned about Rolls-Royce. The basic concept, computer-controlled compressed air. Well, if you have 70 turbines in a row, it's a little bit like a car engine. You don't have all your cylinders firing at the same time. You would have them firing in a controlled sequence as the level of compressed air reached a certain level in each of the pods. So you've got a very, very smooth delivery in terms of the actual hydropneumatic turbines and the production of electricity. The depreciation of the capex components, that's referring to the turbines, not to the actual reinforced concrete structure. So you would obviously have to renew those turbines, going back to the brush, only for going back to the fools and horses scenario, it's one of those. We could probably get through five sets of turbines during the life of the concrete structure. On our calculations, we've assumed a capacity of 40% efficiency, because there's an awful lot of things that would knock out efficiency, but that's not casting concrete. And the surplus electricity, well, following on from what's been discussed here this morning, obviously what we need to do is to find people who would want to buy this electricity. And one of the things that's been put out is data centres, AI centres, and these sort of high use type of organisations. The irony of that is that I personally obtained planning approval for 2 large data centres in St Lawrence 14 years ago, which was going very, very well, until they put the whole project for peer review to BDO accountants, and they went very, very lukewarm on it, and the whole deal collapsed. Otherwise, we'd be standing here today saying, well, we've got 2 lovely big data centres in St Lawrence, which this could power. So there's a little bit of an ironic twist there. And I think Steve Luce was the planning minister at the time. Could we have the next one? Level of demand, well, Jersey Electricity, and this brings me to another main point for me personally. Jersey Electricity cannot produce enough electricity on its own to meet the island's current demands. there is a gap between what they can generate and what is used, particularly at peak. Now, the Jersey Electricity is a fantastic electrical company. Don't make any mistake about that. The number of problems with the electrical supply in the island is absolutely minimal compared with Europe and other places. And the cost of electricity to the island is relatively low, and it's a very, very well-run grid. I'm not here to knock Jersey Electricity, but I'm just saying we don't have complete control over the electrical supply to the island. Now, God forbid, if the 3 interconnector cables went down, or if there was a cyber attack upon the control mechanism in France of the supply of electricity to Jersey, and we were cut off from electricity, then we would have some real issues over here. And what I'm proposing here today would produce electricity on island, so we would have some security of supply that we don't currently have. And as I say, for me, that is actually quite an important point, because I hark back to the time when Jersey produced all of its own electricity, but that was more expensive than using the nuclear stuff from France. Next slide, I think that's... I've also put a little comment at the bottom there, a little planning comment, because obviously it would involve the rezoning of part of the land that we're talking about. But it just so happens that the Bridging Island Plan, under which we're all operating at the moment, is due for renewal right now. The Bridging Island Plan was put in place in 2022 to last until 2025, and the planning department are going to have to start rezoning or changing some of those policies to meet that statutory requirement. So from a timing point of view, then if we could have a little bit of a strip of land down by the harbour rezoned for tidal energy recovery system, then I'd be very happy. And that, ladies and gentlemen, is it in a nutshell. Thank you very much.
Thank you very much. Hold on to that. I'm going to start with my first question. Just a sec here. Sorry, I'll start with the first question. So the one area of concern for any citizen is, what would be the cost of the electricity? Do you feel you could compete with the, let's say, the new French contract? Because ultimately, I'm just standing there and saying they're going to come up with a price which we don't know, but you're going to come up with a price that the investors who are putting all the capital into this would do. What's the kind of range you think would give the capital investors sufficient return and getting a price and the customer paying? What's your range?
One of the previous speakers put up a copy of the Rance barrage that said the price of electricity generated by the Rance barrage was 4 times that of the normal cost of electricity. I don't think that's quite correct. But the beauty of this scheme is that the actual price of production of electricity would be subsidised by the other income streams that it would attract. So in terms of the cost of electricity, I could stand here and say, I think we've got a pretty good chance of producing electricity at a competitive price. And that's about as far as I would go at the moment, Graham.
Well, fair enough. And what you're asking for is a chance to dig into this a little deeper and keep it on the table. I think that's really...
Yeah, I think I'm just asking for tidal energy to be considered rather than, for some reason, being completely ignored. I think tidal energy has got a lot of good points. I mean, first of all, it's not intermittent. The tide comes in and out twice a day, regular as clockwork. It doesn't matter whether there's clouds in the sky or it's dark and nothing's happening solar. It doesn't matter whether the wind's blowing too hard or not blowing enough. The fact of the matter is tide is something that's measured. Also, we have an enormous amount of data with EDF in terms of the Rance barrage. It's gone back to 1966. They can tell us pretty accurately, and it's on public record in France anyway, which is what we've looked at. So you're not comparing apples with apples, to use an old term.
Okay, now I'll go to the tougher questions and turn to the panel.
Yeah, these are the tough guys.
I'm going to be trying to be nice here because I think it's great, the idea you're coming up to. The one in France actually has a capacity factor of 24%. That's a
Right. Okay.
So I don't see you're going to get 40%. I don't see that as possible.
Okay.
That's number one. And when you're comparing to, I almost think the idea is good enough without electricity production, by the way. the 6 pence per kilowatt seems to come back and haunt me.
Yes, well, that's been scrubbed. I didn't mention that.
Then that didn't happen. So I think you'd have to halve the amount of electricity you get out. More.
Right.
And all of that, 20%. And so when you're comparing it to, it is intermittent. It's a known intermittent because the tide accelerates slowly and reaches peak halfway through. So it's better getting
right.
So your tide, the production is like this.
Right.
Right. So it's a known cycle.
Yes.
And that's easier to do.
Yes.
But it is intermittent.
Yes.
And you have no storage. So, but I actually think, I give it 10 out of 10 for putting it all together with the landfill and everything else.
Thank you very much.
So, that's my view. But I do know your yield factor must be wrong. I'm sorry.
No. Point taken.
And all you have to do is take what branch give out.
Yes.
And branch is a tiny installation. Branch only gives out a regular 126 megawatts.
Right.
That's all that. Right. And really, it's a roadway. That's
yes, it was a...
Liverpool's proposed one, which is a roadway, same like all the shield. I've done a study on that, which only takes me 10 minutes. And theirs works out at 200 times the cost, doesn't it?
Right.
But tidal energy, in terms of capital costs, for tidal barrages, is 52 times the cost of gas.
Yes, tidal barrages are more expensive.
And so on. But yeah, so I'm just giving you an idea. But I think 10 out of 10 investigate it further.
Thank you.
You?
Yeah, well, I guess I would echo what all of you are saying. Approaching this talk, I would usually have thought the talk with tidal energy was going to be bonkers. I did some plotting of tidal energy many years ago.
Yes.
It's on here. But uncontrolled tidal energy provides you with 4 peaks in production.
Yes.
The tide is coming in and the tide is
going out. Yeah.
And going out. And the time that appears moves from day to day. And the amplitude also changes with time due to space.
Yes.
And if I understand correctly, that your proposal is to try to store lots of bits of this energy
correct.
Sequence it along this so that
yes.
it can be released.
Yes. To smooth out. That's exactly
that in itself is an excellent idea, in my opinion.
Thank you.
Wish you luck.
Thank you.
Being very kind to you.
I wasn't expecting that, by the way.
Okay, let's have some questions from the audience.
I've only got a few more minutes because Alex has got to follow. He's got a plane to catch. I've only got a bus to catch.
Be able to answer the question, but anyway, let's go for it. When we do landfill,
yes.
It does have an impact on tides, not in that particular area,
no.
But in other areas. Down at Rev Desert and to Green Island, there were some changes in the way the tides reacted when we did those landfills out. Have you actually considered, by putting out some more landfill, could that actually impact on tides elsewhere, the tidal flow elsewhere?
My understanding is that it's the currents through the rocks and the gutters that are affected by this sort of arrangement.
Water is also that's correct.
In this case, you already have the Elizabeth Castle breakwater, which runs across where the main tide comes in. But this is hides behind that. And where the Dog's Nest rock is fairly shallow in terms of the bay itself. So yes, it probably would have some impact, but I don't think it would be one where large amounts of sand start to move around or bits of beach disappear and so on like that.
Certainly do down
But,
the Rev Desert. You could see.
I think the great thing about what you're saying is, and what we obviously need to do here is have a proper marine survey, not just of the entrance to the harbour, but that whole round by Halfday Par and all the way along St Clements and past Green Island. We would need to do a proper survey.
I don't want to come across as being negative.
No, not
it's
at all.
just about consideration, because somebody will mention it.
I mean, no, I have no problem with that at all, because that's far easier to deal with than nuclear waste.
Thank you.
Okay, another question over here.
Genuine question. I'm not a sailor. How do you, these days, how do they deal with fouling? You used to have anti-fouling paint in your boats and stuff.
Yeah,
So how do you stop the...
Well, the reinforced concrete pods, the 10 metre by 10 metre reinforced concrete pods, which is where the water would enter and then rise as the tide comes up, would have, say, 1 metre diameter holes underneath low water mark. So yes, you would need to clean those occasionally for weed and barnacles and all the rest of it, so it doesn't become too restricted. But because there are no moving parts, because there would be nothing in the salt water, it would be a fairly rudimentary arrangement, more along Roman lines than 2025, where the water simply rises up in a large box and compresses the air, and then you do what you can with that 100. Well, it's 10 to the power 6, isn't it? It's 1 million cubic meters of air in each pod, and there are 70 of them.
Yeah, thanks. So you wouldn't be spending endlessly trying to...
Not at all.
Clean out the...
No.
You'd be losing energy in heating of the air as well.
Yeah, yeah.
And then you'd be losing energy again in the turbine.
Yes.
And I would draw my 24% to a be below 20.
It'll be below, right.
So the
For 100
challenge
years.
What?
For 100 years.
So you'd need 12 of these. You'd need 12 of these to equate to 1/300
Nuclear. Yes, but I think the thing about the nuclear is the massive overcapacity for the island.
No, it wouldn't happen without the custom.
Right,
Exactly. The same old formula.
same old formula.
So this would be, if we didn't go that big, that the modular nuclear reactor kind of demands the economy of scale to put it in, this would be another option. So I think this is, what has impressed me is, here's a local Jersey guy aware of what's going on, combining different needs and coming up with a creative idea. I know you don't have all the answers because this is at the early days, but I want to compliment you on the work you're doing.
Thank you.
And let's see where it goes. Thank you.
Thank you.